What is the Model Context Protocol? For short, what is MCP? MCP Model Context Protocol is an open source standard for connecting AI applications to external systems. The special language for servers and LLMs. Your ChatGPT can connect to your servers, get data, or execute programs on your computer, find in browser information if you give a task, such as, hey Llama, send me list news, can you parse this in my browser? And then MCP server special can start Gecko driver at this browser driver like Firefox and use Google search engines and get data and write to you. Alright, MCP is an open source standard for connecting AI applications to external systems. In addition, we can say, hey Llama, what weather today? Hey Llama, open my door, enable light, enable relay, get data from Arduino, Raspberry Pi, print in a display image, get from internet. Using MCP, AI applications like Cloud or ChatGPT can connect to data sources, databases, e.g. local files, databases, tools, search engines, calculators, and workflows, e.g. specialized prompts, enabling them to access key information and perform tasks. Think of MCP like USB-C port for AI applications. Just as USB-C provides a standardized way to connect electronic devices, MCP provides a standardized way to connect AI applications to external systems. Let's check image. MCP protocol or language, special language for ChatGPT to your databases, servers, MCP servers. ChatGPT, Llama, and other AI agents use MCP client in here using protocol. Clients, we make prompt. MCP client send requests to MCP server, and MCP server gets data from databases, or save files to our system, or open browser and open maps and find coordinates and different places by our prompt description. And this MCP server using protocol sends answer to MCP client, and client make prompt to LLM model like ChatGPT, Llama, Cloud, etc. And we get data from database or coordinates or message about that file saved, or git make merge in master branch. Let's check IE applications, chat interface, cloud desktop, Libra chat, IDEA, ITM for code can be used, MCP servers, cloud code goes, other applications, Fire super interface, MCP standardized protocol, data in file systems, PostSQL, SQLite, Google Drive. We can say, hey Llama or hey ChatGPT, save my files into Google Drive, and client get prompt sends message to server get our files from our computer and send to Google Drive. We get the message about it, and IE agent say to us our files saved or in process. Development tools, Git Sentry, etc. Productivity tools, Take, Google Maps, etc. Data sources and tools. For example, we can say, hey, are you planning to in the next day go to my friend? Can you add in my calendar? And then, oh ma'am, we put our prompt, MCP client using protocol send request, RESTful API, if you know, and MCP server get our message or prompt about plannings, and go to calendar, Google Calendar, and add event as the next day. Okay, data sources and tools, IE applications, and this standardized protocol or like USB-C port to connect IE applications to data sources and tools and other systems. What can MCP enable? Agents can access your Google Calendar and Notion, acting as a more personalized IE assistant. Cloud Code can generate an interweb app using a Figma design. Enterprise chatbots can connect to multiple databases across an organization, empowering users to analyze data using chat. IE models can create 3D designs on Blender and print them out using 3D printer. Really? Why does MCP matter? Depending on where you sit in the ecosystem, MCP can have a range of benefits. Developers, MCP reduces development time and complexity when building or interacting with an IE application or agent. IE applications or agents. MCP provides access to an ecosystem of data sources, tools, and applications, which will enhance capabilities and improve to the end user experience. End users. MCP results in more capable IE applications or agents, which can access your data and take actions on your behalf when necessary. Okay, architecture overview. This overview of the Model Context Protocol, MCP, discusses its scope and core concepts and provides an example demonstrating each core concept. Because MCP SDK is abstract away many concerns, most developers will likely find the data layer protocol section to be the most useful. It discusses how MCP servers can provide context to an IE application. Data layer protocol. Okay. Client server. Okay. Let's wait. For specific implementation details, please refer to the documentation of language-specific SDK. TypeScript, Python, Go, Java, Swift, Kotlin. This means we can use MCP clients and connect to MCP servers using Android apps. Or desktop applications. Get statistics, analyzing, make prognosis, get data, save in database, and in a periodic try and prognosticate how many vegetables we get, fruits, if we implement system in greenhouse. Okay, scope. The model context protocol includes the following projects: MCP specification, a specification of MCP that outlines the implementation requirements for clients and servers. MCP SDKs for different programming languages that implement MCP. Okay, this is like library for different languages, but this abbreviation: MCP development tools for development MCP servers and clients, including the MCP inspector. I check. Inspector, visual testing tool for MCP server. This is like developer tools for web, but for MCP. For developers, development tools. Yeah. MCP reference server implementations. Reference implementations of MCP servers. MCP focuses solely on the protocol for context exchange. It does not dictate how IE applications use LMMs or manage the provided context. What means context? Concepts of MCP participants. MCP follows a client-server architecture where an MCP host, an IE application like Cloud Code or Cloud Desktop, established connections to one or more MCP servers using client. ChatGPT sent his prompt to. We sent prompt to ChatGPT. ChatGPT sent a request to MCP client, and MCP client using MCP protocol send requests to MCP server. Server get files, data, save files, delete files, write and change files, and return status about operation, or return data from files like databases. Established connections to one or more MCP servers. Any application like Cloud Code established connections to one or more MCP servers. We can use more than one. The MCP host accomplished this by creating one MCP client for each MCP server. One client, more servers. Each MCP client maintains a dedicated connection with its corresponding MCP server. This means MCP clients send requests, get, post, and etc. This architecture you can read about RESTful API. What is it? What is it? Local MCP servers that use the STDO input-output. Local MCP servers that use the STDO transport typically serve a single MCP client, whereas remote MCP servers that use a streamable HTTP transport will typically serve many MCP clients. Other words, STTO transport means the MCP server use STTLib to access file data. Using this lib, STTLib, you can find in Linux, in C++ code and different languages. We use this lib to save files, read files, delete files, etc. But clients, MCP clients use HTTP protocol to send requests. Other words, MCP client use Internet protocol, not local libs. He create packages, package, TCP package, UDP package, using TCP, and send this package to server, understand package, read file, and send answer, or database, or something. Local MCP servers that use STD transport or local library for reading, for input-output operations, when input means write data, output means read data, typically serve a single MCP client. Local MCP clients. Okay, whereas remote MCP servers that use streamable HTTP transport will typically serve many MCP clients. These use an HTTP request, and server use HTTP request plus use stdlib to access files. I don't know why this edits in here. This is not important, I think. The key participants in the MCP architecture are MCP host, the IE application that coordinates and manages one or multiply MCP clients. MCP client, a component that maintains a connection to MCP server and obtains context from an MCP server for the MCP host to use. I think context means when we send prompt to AI agent like ChatGPT save or prompt and think about it when make next answers. And MCP server and MCP clients use this context too. Maybe a component that maintains a connection MCP client AI agent using client MCP client use server MCP server and give context not give and use context like we make prompt get data and get data is a context in this term. These sentence used to form request for MCP server. When request format by client, request send it, and then MCP server make answer. We need data in a file agenda 123.txt and server return all strings in this file. MCP server, a program that provides context to MCP clients. This means AI agent think that he has access to data. AI agents don't know that he sent requests. He not sent request. MCP client listen his prompts in a special protocol and form requests for server. Okay. For example, Visual Studio Code acts as an MCP host or RPC or terminal client like this name MCP client for Olama I testing tool and get data from local server using fast MCP in a Python. This write a easy program. Okay. No. I want to show how this program like gets data. These like functions with decorator. I can make function and return data. This not used. This just a logger to terminal printing. I can just return data. This not correct code. This old code. Serve. See, we used fast MCP and JSON, not. And this is for saving into file data. See, just two functions This is MCP2. I can say get data from sensors, and MCP client can ask me execute this tool or not. Every functions means MCP2 or not every. And this form prompt and MCP client form request to MCP server. I start server and MCP client send request in this URL, and then get data from function, temperature, and etc. This data in here in the client. Server send answer. Okay. For example, Visual Studio Code acts as an MCP host. In here, my computer is a MCP host. In this host, I execute MCP client that communicate with server. This server can be started in a different machines, different computers, like mini PC, maybe phone, maybe web application, maybe public servers where you can get data. We can start servers in the different computers, in the web, in the servers, in our computer too for local testing. This URL can be google.com, MCP server, and ports can be used, or my site MCP if we using domain names, not IP addresses. Okay, client and server, and these communicate using HTTP RESTful API or special protocol. Visual Studio Code acts as an MCP host. When Visual Studio Code established a connection to an MCP server, such as Sentry MCP server, I think Visual Code can use copy load his has client to established connection to MCP server on Microsoft data center servers and generate codes, fix errors, etc. The Visual Studio Code runtime instantiates an MCP client object that maintains the connection to Sentry MCP server. That I say. When Visual Studio Code subsequently connects to another MCP server, such as local file system server, when Visual Studio Code connects to another server, such as local file system server, the Visual Studio Code runtime instantiates an additional MCP client object to maintain this connection. Object means as in a code when we create instance of a class. Instance 1, 2, 3, 4. But client program 1 if you know. The Visual Studio Code runtime instantiates an additional MCP client object for file system access. Or computer can be run at file system server 2. This MCP server, like Microsoft data center in internet and local file system server, maybe MCP host IE application, MCP client 1, dedicated connection, MCP server A, local, AG, file system, MCP client 2, dedicated connection, MCP server B, local, for database, MCP client 3, as you can see, dedicated connection to MCP server C, but it is not a local server, this is remote to Microsoft servers or another Google ChatGPT cloud, and some things. MCP client 4 dedicated connection, remote to instances and a class to object. This object can be used to Visual Studio or another client, another programs. I don't know. Note that MCP server refers to the program that serves context data regardless of where it runs. Context data means file system data, database data, code generation data, code snippets is generated by or prompts. MCP servers can execute locally or remotely. For example, when Cloud Desktop launches the file system server, the server runs locally on the same machine because it uses the STDO transport. In other words, server can write, read or files because he uses stdlib input-output library to access and manage our file system. This is commonly referred to as a local MCP server. The official Sentry MCP server runs on the Sentry platform in data center and uses the streamable HTTP transport, uses Internet Protocol, in other words, special organization of bytes, and this byte send it by your Wi-Fi card or Ethernet cable to another computer, and the drivers interpret this as packages used by applications or programs like Python scripts can interpret them and get various data and save this in a local file system. This is commonly referred to as remote MCP server. Remote use HTTP. You can learn about HTTP, the network protocols. Just Google. Use Google or DACI or ChatGPT and make questions. Layers. MCP consists of two layers. Data layer defines the JSON is a special format to send data. This is like this. Not just in string A equal 1, B equal 2, but special format when we use value key format in brackets, and we can create more strings. Data layer defines a JSON RPC. RPC means JSON standard. You can find how I know the standard. Defines a JSON data layer defines a JSON RPC based protocol for client-server communication. This standard means how data sent by server to client, client to server. Okay, this includes lifecycle management and core primitives such as tools, resources, prompts, and notifications. In MCP defines protocol for communication, including lifecycle management, core primitives such as tools, resources, prompts, and notifications. Transport layer defines the communication mechanisms and channels to enable data exchange between clients and servers, including transport-specific connection, establishment, message framing, and authorization. Conceptually, the data layer is the inner layer, while the transport layer is the outer layer. These abstractions added to easy understand, but not easy. Transport layer, I think, means RESTful API, TCP packages, HTTP requests, and other words how our computers communicate with other computers, where my computer can be client and server, and MCP client sends request to server, and server sends answers. Mechanism of how he communicate, local or remote, maybe. The data layer implements a JSON RPC 2.0 based exchange protocol that defines the message structure and semantics. This layer includes lifecycle management, handles connection initialization, capability negotiation, and connection termination between clients and servers. Okay, server features enables servers to provide core functionality, including tools for AI actions, resources for context data, and prompts for interaction templates from and to the client. Client features enable servers to ask the client to sample from the host LLM. LLM means language large model or AI agent like ChatGPT. Client features enable servers to ask the client to sample from the host LLM, explicit input from the user, and to log messages to the client. Utility features supports additional capabilities like notifications for real-time updates and progress tracking for long-running operations. Transport layer. The transport layer manages communication channels and authentication between clients and servers. It handles connection establishment, message framing, and secure communication between MCP participants. MCP supports two transport mechanisms. STDO transport uses standard input-output streams for direct process communication between local processes and on the same machine, providing optimal performance with no network overhead. Yes, STDO, this is library that uses files in Linux systems as streams. He writes bytes in a, in a streams, in a files saved in a or hard disks or other storages. Streamable HTTP transport uses HTTP post for client to server messages with optimal server send events for streaming capabilities. This transport enables remote server communication and supports standard HTTP authentication methods, including bearer tokens, APKs, and custom headers. MCP recommends using OAuth to obtain authentication tokens. Authentication can be used to secure our servers to prevent inaccessible actions like get data from our database. The transport layer abstracts communication details from the protocol layer. Abstracts communication details from the protocol layer, enabling the same JSON RPC 2.0 message format across all transport mechanisms. In other words, client and server uses HTTP post requests and TCP packages form, where 0 and 1s encoded into special structure form and sent by machines and interpreted. Get data, additional informational data, etc. Data layer protocol. A core part of MCP is defining the schema and semantics between MCP clients and MCP servers. Developers will likely find the data layer, in particular, the set of primitives, tools, resources, prompts. In particular, the set of primitives to be the most interesting part of MCP. And this part of MCP that defines the ways developers can share context from MCP servers and MCP clients. MCP uses JSON RPC 2.0 standard as its underlying RPC protocol. Client and server send requests to each other and respond accordingly. Notifications can be used when no response is required. Lifecycle management. MCP is a stateful protocol as it requires lifecycle management. The purpose of lifecycle management is to negotiate capabilities as it both client and server support. Detailed information can be found in the specification, and the example showcases to initialization sequence. MCP stateful protocol that requires lifecycle management. What means lifecycle management? What means capabilities? Is it both client and server support? Specification example. Let's check specification. Lifecycle, client, initialization phase, initializate request, server initializate response. Okay, client send request, server interpret them, and generate response. Can be initialized notification, variation phase, normal protocol operation, shutdown, and client get response, send to server, hey, I get response, and disconnect. Okay, lifecycle means just how client and server communicate. These are abstractions to the network protocols. What example? Data layer. This section provides a step-by-step workthrough of the MCP client-server interactions, focusing on the data layer protocol. We will demonstrate the lifecycle sequence. HTTP package. 2 operations and notifications using JSON messages. Initialization. Initializate request. JSON standard ID method initializate parameters, capabilities, protocol version, client info name version, response, client automatically send request initializate, server answer, results, he say what version he used, protocol, utilization, notification, how this works, no, to discovery, tools, list request. We client, MCP client say, hey, what tools I can use? All the words, what applications can I use? Or functions in Python code. If we use self-script, self-write. And server say, hey, you can use calculator. You can check weather information, etc. Descriptions, some things, what we can do, how, weather, city name, properties that we need. Say, for weather we say property city name, address or coordinate, and we get unit temperature. Okay, primitives. MCP primitives are the most important concept within MCP. They define what clients and servers can offer each other. These primitives specify the types of contextual information that can be shared with IE applications and the range of actions that can be performed. MCP defines 3 core primitives that servers can expose. MCP defines 3 core primitives that servers can expose. Tools, resources, prompts. Tools, executable functions that IE applications can invoke to perform actions, like file operations, API calls to get wizard data, database queries, etc. Write data to file, get string from database, make API request to server to get maybe maybe list posts of your friends in his social network page. Resources. Data sources that provide contextual information to applications, file contents, database records, IP responses. Data sources answers from our tools. We use a tool to make request. Hey, get from database all list records about my sensors, and this used as resource. Database means data source where records, and in context for IE application, these records used for answers to user to form answer in markdown format. How in here I use it to get data from sensors. This function in my MCP server. And then this using this tool, MCP client sends request and get response. Response in JSON RPC format to 0. And then but this can be used in context by MCP client if we enable this function. As storage. We get data and we can use next tool and say, hey, can you send this data to my database server, or can you save this to file, and etc. Or can you send this to my messenger? Can you this data analyze or save to statical program in my computer if this program may be written and used. Okay, prompts. Reusable templates that help structure interactions with language models. AG system prompts. Few short examples. Templates like this, and this. Text templates. Templates used by MCP client to say or maybe not IE agent, but in this MCP client use llama indirectly and prints his answers in here. This template using when I use tool and when clients asking me use this tool or not. Template options. When I say yes, he used template for response in a markdown format or special with styles, with colors, with color text, etc. Each primitive type has associated methods to discovery, list, retrieval, get, and in some cases execution tools call. I think this means template name. Maybe tools call this template list like this or this template, and get, I don't know, maybe what you would like to do, asking user and answer response. MCP clients will use the list methods to discover available primitives. Maybe this means older. You can forget what I say about templates. Let's read. Continue. Each primitive type has associated methods for discovery, list, retrieve, get, and in some cases execution tools call. MCP clients will use the list methods to discover available primitives. For example, a client can first list all available tools and then execute them. This design allows listings to the dynamic. In this client, MCP client for Llama, he prints available tools. This is template. Okay. As a concrete example, consider an MCP server that provides context about a database. It can expose tools for querying the database, a resource that contains the schema of the database, and a prompt that includes few short examples for interacting with the tools. Oh yes, MCP clients can be GUI with graphical interface, not CLI, not terminal. But I tried terminal. For more details about server primitives, see server concepts. Just list, not read, just check. Understanding MCP servers. Who control model, application, user, we control prompts. Application control resources like database, tools, or control model. Resource template example. Name, title, description. Get to the first, search. These templates, I think when we say, hey, get wizard and template, okay, we search available flights between cities, or get feather, wait please. Or not. MCP also define, MCP also define primitives that clients can expose. These primitives allow MCP server authors to build richer interactions. Sampling allows servers to request language model completions from the client's IE applications. This is useful when server authors want access to a long language model but want to stay model independent and not include a language model SDK in their MCP server. They can use sampling complete method to request a language model completion for the client's AI application. Allow servers to request language from the AI application. This is useful when authors want access to model but not include SDK on their MCP server. They can use this template method to request the language model to completion. I not understand. Just continue. Elicitation allows servers to request additional information from users. Maybe asking. This is useful when server others want to get more information from the user or ask the confirmation of the action. This client not ask additional information and make mistakes, but this make confirmation ask. Okay, they can use the elicitation request method to request additional information from the user. Logging enables servers to send to log messages to clients for debugging and monitoring purposes. For more details about client primitives, see client concepts. Let's check understanding MCP clients. MCP clients are initiated by host applications to communicate with particle MCP servers. The host applications like cloud or IDE manages overall user experience and coordinates multiple clients. Each client handles one direct communication with one server. User, human interaction, user, client, server, complete request, initiate allocation, present allocation UI. User make prompt and server send template to ask user additional information, and then when client get from user requested information, this create a request sent to server, return user response, and server continue processing with new information. Simple flow. LMMM user client server. User sampling, create message, present request, review, modify model direction, forward, generation, respond to review, complete request, human in the loop review. Okay, user sent a request. This send it to client, modify it, and then send it to LMMM. LMM return generation in a template. Client present response and review and modify. Okay, MCP client modify user requests, and LMM AI agents like ChatGPT, Llama, and etc. modify answers, and then form requests in JSON format and send to the server. Button here, server initiates sampling, and client send return upload response. And this I not understand what it means. What means sampling? Create message. Where clients send to the server messages. Interesting. Complete request. These interactions sampling server client server, and when in the generated complete request a return approved response. I don't know. Okay, we return to architecture. Besides server and client primitives, the protocol offers cross-cutting utility primitives that augment how requests are executed. Tasks, experimental, durable execution wrappers that enable different results retrieval and status tracking for MCP requests, e.g., expensive computations, workflow automation, batch processing, multi-step operations. Notifications. The protocol supports real-time notifications to enable dynamic updates between servers and clients. For example, when a server available tools change, such as when new functionality becomes available or existing tools are modified, the server can send to update notification to inform connect clients about these changes. Notifications are sent as JSON RPC notification messages without expanding a response to enable MCP servers to provide real-time updates to connected clients. Real-time notifications are sent by servers to clients using JSON. Server can send update notifications to inform connected clients about these changes. Okay. Example, data layer. This section provides a step-by-step walkthrough of the MCP client-server interaction, focusing on the data layer protocol. Will demonstrate the lifecycle sequence to operations and notifications using JSON messages, initialization, lifecycle management. MCP begins with lifecycle management. The role capability negotiation handshake. Just send a request. As described in the lifecycle management section, the client sends an initiate request to establish the connection and negotiate supported features. Again, initiate this, say, in params version protocol, client info version, client, and version of server, and protocol version, and tools, list changes, resources, I don't know. This say we can use tools, let's change it. I don't know. Understanding the initialization exchange. I make pause. And we continue.